The evolution and applications of virtual human technologies in defense and research. Virtual humans have emerged as a critical area of research within defense, healthcare, and educational contexts, serving as interactive, intelligent digital representations of people designed to enhance training, support therapeutic interventions, and facilitate human-computer interaction. Over several decades, efforts documented within the Defense Technical Information Center, DTIC, have shaped the understanding and application of virtual humans, providing a foundation for realistic simulations, social modeling, and cognitive engagement. The objective is to examine the chronological development, dominant research areas, significant systems, institutional contributions, broader applications, persistent challenges, and anticipated future directions of virtual human technologies based on TTS-sourced work. The development of virtual humans began with early animated agents in the 1990s that primarily focused on graphical representation within networked virtual environments, progressing in the early 2000s toward modeling emotions, cognition, and natural behaviors. From 2007 onward, researchers increasingly emphasized social interaction, with virtual humans becoming capable of responding to users with a degree of emotional intelligence. Between 2010 and 2014, applications expanded into healthcare, with virtual patients and therapy-focused systems gaining prominence. Subsequent years saw advancements in dialogue systems, autonomous agents, and scalable deployment through mobile and mixed reality platforms, culminating most recently in a strong research push toward integrating ethical behavior modeling and real-world deployment readiness. Research into virtual humans within TIC resources has been structured around several major themes, including the use of virtual humans for military and educational training, where they serve as instructors, teammates, or negotiation partners in highly realistic simulated environments. Healthcare applications have leveraged virtual humans for patient interaction, therapy support, and clinical interviewing, offering scalable solutions for sensitive interactions. Emotional and social modeling research has focused on equipping virtual humans with the ability to recognize, express, and respond to human emotions credibly. Work in behavior control and motion modeling has sought to fine-tune the detailed nonverbal communication elements necessary for realism, while dialogue system research has emphasized natural conversation management. Physical and ergonomic modeling has further enhanced the realism of virtual human experiences, simulating stress responses and body dynamics. Key systems developed during the course of this research include the Virtual Human Toolkit, a modular platform enabling the creation and study of virtual humans across various domains, and the Mission Rehearsal Exercise, MRE, which integrated story-based training scenarios with emotionally responsive characters. SimCoach represents an important advance in using virtual humans to support mental health care, particularly for veterans. The Austin architecture and similar frameworks have provided the underlying computational models necessary to integrate cognitive, emotional, and behavioral elements into believable digital characters. Additionally, the development of virtual standardized patients has contributed significantly to medical training by offering repeatable, controlled scenarios for clinical education. The University of Southern California's Institute for Creative Technologies, USC-ICT, has been a central institution driving virtual human research, producing many foundational systems and theories that have shaped the field. Key contributors, such as Jonathan Grach, Stacy Marcella, and David Traum have led efforts in emotional modeling, dialogue management, and social simulation. These academic efforts have been closely tied to Department of Defense initiatives, ensuring that virtual human research remained directly applicable to military training, operational support, and simulation-based education, while promoting collaborative work across governmental, industrial, and academic sectors. Although much of the original motivation for virtual human research came from military needs, its applications have extended into broader fields such as civilian education, mental health therapy, customer service simulations, and cross-cultural communication training. Educational systems now use virtual humans to create realistic scenarios for developing negotiation, counseling, and interpersonal skills. In healthcare, virtual humans serve as non-threatening interfaces for therapy and health education, while businesses and customer support initiatives explore them as scalable, reliable interaction agents. The growth of virtual reality and augmented reality technologies has further broadened potential applications, integrating virtual humans into immersive, mixed reality environments. Despite substantial progress, several challenges persist in advancing virtual human technologies. Achieving social and emotional realism remains difficult, particularly in nuanced or high-stress scenarios. Scalability and cost barriers limit widespread deployment outside research settings. Cultural modeling and ethical concerns, such as ensuring that virtual human behaviors align with diverse user expectations and avoid manipulation, are increasingly important. Open issues also include improving the autonomy of virtual humans without compromising transparency and user trust, suggesting that future research must continue addressing the complex intersection of technology, psychology, and ethics. The progression of virtual human technologies within the TIC record highlights a transformative trajectory from simple animated figures to sophisticated agents capable of nuanced emotional and cognitive interactions. These advances offer significant implications for training, therapy, education, and broader human-machine interaction frameworks. As research continues, virtual humans are poised to become an integral part of simulation environments, healthcare interventions, and adaptive learning systems, with the potential to redefine standards for realistic, responsive digital interaction across both military and civilian domains.